Okay, chapter 3 continuation. Next, LEB rule. LEGB rule 3.3, which is LEGB rule. Okay. Scope also defines the order in which variables have to be mapped to the object. Scope also defines the order. Defines the order in which variables have to be mapped. In which variables have to be mapped in order to map to the object in order to obtain the value. In order to obtain a value. So scope is also defines the order in which variables have to be mapped to an object so that we can get the containing value, proper value for that object. So let us consider this example. Consider this example. First, we are assuming x is equal to outer x variable. Outer x variable. Okay. Then we are displaying it. We are using display function. In this display, x is equal to inner x variable. Inner x variable. Okay. Now I am going to print the value of x. So print x, and again using the function display. When the above statements are executed, the statement 4 and 5, 4 and 5 will display the result. Fourth one will print as corresponding output. On obtaining fourth one, the result will be outer x variable. Outer x variable. But using display, if you print the value, it will print inner x variable. So this means outside the scope, and we are using inside the scope. So in this example, x variable is same. It doesn't change. But the value we are obtaining for x, that is changing because x resides in different scopes. See, here x value is outer x variable, and here x value is inner x variable. X is referenced outside the function definition. X is referenced outside the function definition, so its value is changing. When display gets executed, inner x variable is printed when x value inside the function definition. So the LGB rule is used to design uses of LEGB rule. LEGB rule is used to design the order in which which the scopes to be searched for to be searched for scope resolution. The scopes are listed below in terms of hierarchy, that is highest to lowest. You can see which scope has highest value and which scope has lowest value. Local L defined inside a function class. Local L enclosed within bracket short form as global G and built in, which is okay. We shall see its corresponding definition. So this is its definition. See, for local, it is defined inside function or class. For enclosed, it is defined enclosing function. For global, it is defined at uppermost level, just initial state itself. For built-in function, reserved. The names are reserved. We cannot change anything. So built-in is the default one. Global can be used on starting of the program. Enclosed can be used within a particular function and local can be used for the particular value. Is it clear? Okay. We are going to the next topic. Types of variable scope. Types of variable scope. Okay. There are four types of variable scopes. There are four types. We shall see one by one. First, we can list out what are the types. First, local. Local scope. Second, global scope. Third, enclosed scope. And last one is built-in scope. So first we can see about global local scope. Local scope. Okay. Local scope refers to variables defined in current function. Variable defined in variable defined in current function. Always a function will first look up for a variable name in its local scope. Function will first look up. Function will first look up for a variable name in its local scope. Variable name in its local scope. Only if it does not find it here, the outer scopes are checked. Only if it does not find it there the outer scopes are checked. Outer scopes are okay. First, the variable defined in the current function. Initially, the function will check whether the variable is available for local scope. If it is not there, and it will look for the outer scopes. Now we can see about an example for local scope. Okay, we can see an example for local variable, local scope. Okay, listen. This is the program, and here it's a block of program, and it's out. Okay. We are using display as a function. In display, we are giving value for a as 7, and we are printing a, and we are calling a display function. So the value will be printed as 7. Entire program. In display function, value of a is equal to 7. We are going to print a. Value will be printed as 7. Again, we are calling display. So output of the program will be 7. Here, the value is given inside the function local scope. Then next we are going to see about global scope. Next we are going to see about global scope. For global scope, variable can be declared outside all of outside of all the functions in the program. Declare outside of all the functions. This means global variable can be accessed inside or outside all the functions. Global variable can be accessed inside or outside of all the functions. Now we can see an example for the global scope. Okay, this is an example for global scope. Listen. Static itself, we have declared the value a equal to 7. Displaying a equal to 10 in initial, we have given the value of a as 10, but in display function, we have given the value as 7. Now we are printing the value of a, which is inside the function. Function starts here and ends here. Okay. Display a value as 7, printing the value of a. I think here 1 will come. Display 1. In this, we are printing a alone. So listen, in this function, the value of a acts as 7, but on the entire program, the value of a is 10. That's why we have obtained for print a, the output is 7, and for next print a, which is global, the value is 10. Here it is local scope. it has A has global scope. Why we are saying it as local means it is given the value as 7 only within the function of display, not outside the function. But look here, the value of 10 is declared globally. So the value, whenever we call A, it will be displayed as 10. This is the function of global scope. Next one is enclosed scope. Enclosed scope. All programming languages permit functions to be nested. A function within another function is called nested function. A variable which is declared a variable which is declared inside a function which contains another function. Inside a function which contains another function definition. Another function definition within it. Within it, the inner function can also access the variable. Inner function can also access the variable of the outer function. This scope is called as enclosed scope. So we shall have an example for this. Listen, function within a function is called as a nested function. Is it clear? Okay. Here, display is one function. In this display, we are going to have another display function which ends here, and after end, we are going to have another display function which started here, and the first display function ends here. Is it clear? Okay. So first we are going to print display function. It is declared as value as 10. Okay. Within the function, another function we are defining display 1 value is 28. Program ends here. Again we are displaying print A. This print A is for this example. So this one will print 10, and again here we are printing A. It will also print 10. We are giving function within a function. That's it. Displays the function. Again we are displaying giving another function within that function. And we can display this one is function started here, and again we are giving display one function ends here. Okay. First function, within the first function we are defining second function. This is what they are given here. Next one is built-in scope. Finally, we discuss about the widest scope. The built-in scope has all the names that are preloaded into the program scope. All names that are preloaded into the program scope. When we start the compiler or interpreter, any variable or module which is defined in the library function, any variable or module that are defined in the library functions of a programming language as built-in or module scope. They are loaded as soon as the library files are imported by the program. They are loaded as soon as the library functions, sorry, library files are imported to the program. Imported to the program. Okay. You can see example for this scope, that is built-in scope. Entire program module that is playing the function, files associated with the software will be loaded. Initially, it will be loaded. Without these libraries, the program cannot be run. So it will be displayed first.